using Flex, right? So let's get started. So quick checklist for application development in Java. So the first thing you will need is to have the JDK. I would recommend a version of 1.6 at least. Then you need to get hold of the Eclipse IDE, and the version I recommend is Indigo. Then you'll have to get hold of the Android SDK Manager. In fact, the version R16 is recommended. And of course, then it depends on how many Android versions, of the operating system that you want to target when you're building the application. So based on every single version that you want, you'll have to download as many SDKs. So for example, Android 2.2 is Android 8 in terms of the API level, and Android 10 is, for example, 2.3. So, depends on how many versions you're trying to build the applications for. And finally, you'll have to get hold of the what is called the ADT plugin for Eclipse. So once you install this plugin, Eclipse is customized, to help you in Android application development. So that's a checklist for if you want to build applications using Java. Let's move on. If you want to build applications using, just a moment. Okay, so here's the checklist for C and C++ development. It is almost the same as the previous case. That is, you'll still need to have all the items which I mentioned for developing applications in Java, but additionally for C and C++ based application development, you will need to have what is called as the Android NDK, and I would recommend a version of R7B. So that is the only extra item in this checklist compared to the previous checklist. All right, so that's for native application development. So let's move on to the final checklist, and this is a completely different setup, and this is for developing applications in Flash using the Adobe Flex SDK. So the checklist in this case is going to be 3 items. You'll have to get hold of the 4.6 version SDK of Flex, and you'll have to use the Flex Builder, which is in fact a product from Adobe. And finally, you'll have to make sure that you have installed the Adobe Air runtime. It's called the Adobe Air runtime for Android. You can get this obviously on Android Market. Okay, so that's, I think, the checklist for the comprehensive checklist for all the applications that we are going to look at in today's webinar. Right. So quick look at the application basics as far as Android is concerned, and I've been pretty careful to only describe those steps which are common to all 3 ways of building applications. That is, this applies to Java, this applies to building native applications, and this also applies to Flex applications. So the next set of ideas and concepts that we are going to discuss are pretty common to all the 3 approaches. So yeah, so let's get started with that. So typically, any Android application that you build is made up of many screens. So you can think of an Android application as being built of one screen at least, but it is obvious that you can have complicated applications that have more than one screen. So, and there is a technical term for which is very specific to Android, and yeah, it is in fact the term activity, as you can see in the second point of this slide. So every screen within an application is simply called an activity, and obviously you take any Android application and it can have one or more activities, that is one or more screens. So here's a quick example, and it is in fact one of the most simplest and useful applications on Android, and which is the alarm clock. So if you observe the first image here on the screen, so that's the shortcut to the alarm clock application. Once you click on it, it starts off and shows you a screen that looks like the second image, the one in the middle. So you observe that this is one activity. What you're looking at right now is one activity, that is one screen. But of course, the alarm clock application has more than one screen. So in this case, what happens is that once this particular activity is seen, then the application flow depends on how it is, how the application is built. So as in this case, as in the case of the alarm clock, you click on, for example, the 7 a.m. You click on the 7 a.m. item, and what you see is the next activity or the next screen. So as the arrows indicate, the red colored arrow indicates the forward flow of the application from one activity to the other, and the blue color arrow indicates the flow back to the previous screen when you click on the done button. So typically any Android application will have a flow that looks like this. So you start with one screen, and then you move to another screen, and then you move to another screen, and then you come back, and so on. So this is how it goes. All right, so let's proceed further here. So you can now imagine that once you have an Android system, on a device or the emulator, whatever the case may be, so you can think of an Android system as a collection of applications. And just as I mentioned, any application is a collection of activities, that is screens. So overall, you can think of an Android system as a collection of many activities. All right. So the point is, it is possible that one activity inside an application tries to communicate or exchange data with some other activity inside the same application. Okay, now that is one possibility, but there is also another possibility, and that possibility is that you can have an activity inside one application, but it is trying to communicate or exchange data with another activity from a completely different application. So for people coming in from a C or C++ background, or even Java, for example, so this is RPC, the concept of remote procedure call, or data exchange between one process and another. So this is more or less something on the same lines. All right, one final point here that I would like to make is, even though an activity can be thought of as a single screen within an application, but you must understand that it is actually two things combined together. There are two things combined together that form an activity, and those two things are: one is there is a layout. There is a graphical representation of how the activity and the components look like. Now that's one aspect. The other aspect is that there is quite a bit of back-end code that is involved. So the point is, these two things are put together and they become what is called as the activity, right? So quick example of the second point which I've mentioned in this slide, that is, one activity from inside one application tries to communicate with another activity inside another application. This is more or less on the lines of a remote procedure call, right? So quick look here. I'm sure most of you might have at least used Google Maps, or for example Bing Maps. So anyway, the point is that Maps as such is a standalone application. So you can imagine that the moment you start the Maps application, you get to see some kind of map, based on your GPS coordinates, based on your location. All right, so the point is, now it is obviously assumed that the moment you start off the Maps application from the phone, it is assumed that you already have the GPS. But it so happens in many cases that people actually forget that the GPS has to be on before you start off the Maps application. So just in case that there is a scenario like this, so what actually happens is that we have the Maps application, all right, and let us assume that you're currently looking at some map, which is the activity inside the Maps application. Now, inside the application, it is very simple to detect that the GPS is not switched on. At this point, what happens is the activity which is currently being seen, which belongs to the Maps application, it tries to invoke another activity which is outside of the Maps application. So you see, this is communication in a way from one process to another process, right? So you can see that in this case, there is an invocation of another activity, and you can see that activity on the right-hand side of the screen. In fact, this is the settings module, or the settings page from Android. So you can go here. The user can go to this page and he can switch on, for example, the GPS satellites setting, so that the GPS is switched on for the phone. And once this setting has been done, you can go back to Maps. So this is the way that you can have actually communication between different applications and different activities within applications. So I hope that is clear. All right. So the next, so in a way we have come to a certain conclusion there, and that conclusion is that any Android application is made up of multiple screens, and each screen is simply called as an activity. So you can think of an Android operating system, the entire Android system, as a collection of activities. Okay. So now the next concept that we have to understand, and again, as I mentioned, this is a generic thing. It applies to Java application development, it applies to C++, it applies also to Flex. So the concept is that of application permissions. So as the first point in the slide says, any Android application must specify the system level permissions that it requires to run successfully. So typical system level permissions, for example, can be let's say you have an application that wants to access the camera. So you'll have to obtain, your application will have to obtain permission to use the camera. Or let's say you have an application that depends on the GPS, so you have to get the permission for that. Let's say your application depends on the SD card, the micro SD card. So you'll have to obtain permission for accessing the micro SD card, and so on. So the point is that any Android application that is built needs to explicitly mention what are the system level permissions that it is expecting so that it can run successfully. So that's a very, very important point. Right, and as a second point says, so when the application is installed for the first time on a device, the user is presented with a list of all the necessary permissions which are required by the application. Let me quickly show you what I'm talking about. If you observe this, the screen here, there is an application, just a fictional application that I call as GPS tracker. So this application needs to have access to the GPS, and it also needs to have internet access. So you see here, as highlighted by the red colored rectangle here in this diagram, that Android is going to display this list of all the permissions which are required for this application to run successfully. So if the user is okay with that, he's going to click on install, the application installs, and it's going to work fine. But in case the user is not okay with that, so he can click on cancel and the application is not installed. Okay, so I think the concept of application permissions is clear. So the point is, when do you see the screen? When do you see this list of permissions? It is seen when you install the application onto the device. So that's that's the point there. So now continuing with the points here. So the point is, when the user has reviewed all the permissions and he accepts them, then the application is installed, just as we saw in the previous screenshot. And the policy, this policy holds good for any Android application that is built in Java, C++, or even Flex. Okay. All right. So that is about application permissions. The next concept that we need to understand is something called as the application manifest. All right. So what exactly is the application manifest? So every application has this so-called manifest file associated with it. And what is inside the manifest file is, in fact, a lot of important metadata about the application itself. So think of this as the file system of an operating system, or the file system typically describes the layout of the file system, and it contains paths to the files and directories. So something on the same lines. So you can think of an application manifest as a file that describes in and out every detail of your application to the Android operating system. All right, and so the manifest file is typically in XML format. It's a custom extension of the XML format. So that is that is the contents of the manifest file are typically XML. All right, and most importantly, the manifest file contains the items in this list, as I've mentioned here in the slide. So it requires, for example, the list of all permissions that are necessary for your particular application. For example, you might be looking out for GPS permission, you might want internet access, you might want access to the SD card. So the application manifest is the place where your application will specify that this is the set of permissions that I'm looking out for, right? And it additionally, apart from the permissions, you will also have to make sure that every single activity that you have within the application. So when I use the word activity, I obviously mean every single screen that you have built within your application. Every single screen has to be represented inside the manifest file. I mean to say, there is a list of every single screen that you have within the application. So apart from that, One of those screens obviously is going to be the first screen that is seen by the user when the application starts. So that in fact is called as the entry point for the entire application. So yeah, so the entry point also should be mentioned inside the manifest file. And of course, finally, there is you can have, for example, some kind of constraint based on the Android version that is expected by your particular application. For example, let's say you built an application that is pretty recent and it cannot run on Android version 1.5 and below. So maybe you can specify what is called as a minimum SDK version. So you can specify that also inside the application manifest. All right, so this is the description for the application manifest. So let's go ahead now. Quick look at what happens in the background when you build and deploy Java applications on an Android phone. So typical flow goes this way. You have the Java source code, which is then passed through the Java compiler. It generates the bytecode, and then the bytecode executes on the Java virtual machine. But in the case of Android, there is a custom Java virtual machine implementation that is called as the Dalvik virtual machine. So in essence, what happens here is a slight deviation of the flow. So the Java source code, goes through the Java compiler, and the Java bytecode is generated. And after this, there is something called as a DEX compiler. The DEX compiler takes this bytecode as the input and produces what is called as the Dalvik bytecode, and then this Dalvik bytecode executes on the Dalvik virtual machine. So there is a quick difference between the way typical Java applications work on a desktop and Java applications working on an Android phone. All right, so quick look at what happens if you